Hello class, and welcome to lesson 6.3, quadratic transformations. If you recall, in unit 4, ladies and gentlemen, we used the graphing calculator to take our parabola and we shifted it left, we shifted it right, we shifted it up, we shifted it down, we stretched it, we compressed it, and we also flipped it upside down. So what we're going to be doing is learning how to do that without using the graphing calculator today, folks. And when we talk about transformations, ladies and gentlemen, we always talk about it from the base function. The most basic form of the quadratic is y equals x squared. So if I take my general equation, which is y equals a bracket x minus p squared plus q, and I let p and q equal 0, and I let a equal 1, which is stripping down every one of those variables that changes or makes transformation, shifting left, right, up, down, then I'm going to be left with the most basic function. So just write down here that this is the base function. When they say to describe the transformations, it's based on your initial base function, the easiest form of the quadratic. All right. So ladies and gentlemen, based on this equation here, we're going to graph it, and you've probably graphed it a couple times already. Let's just quickly remember how we do this. If you want to set up a table of values, that's one way to graph it. Okay, and I'm going to use some negative values, I'm going to use some positive values, and you just substitute in. So it's going to be y equals negative 3 squared, which equals 9. Y equals negative 2. Wherever you see an x, you're putting in your independent, right? So negative 1 squared, guys, equals 1. Be careful here, guys. If you have 0 raised to the exponent of 2, that equals 0. So 1 squared equals 1. Y equals 2 squared, which equals 4. And y equals 3 squared, which equals 9. Hopefully you remember back from Unit 4, folks, when we did a table of values, we looked for the turning point on the y values where it started changing again. And hopefully you notice here at 0 is the turnaround point, okay? And remember, folks, we used to call that the vertex, okay? Same as when we do it this way. All right. So I'm going to label my graphs, x and y, my axes. I'm going to give a scale of 2 to negative 2. Negative 2, if you like a different number, go ahead and do it. 2s are just easy for me so you can see them. Now there's two ways you can graph this, ladies and gentlemen. I'm going to show you the shortcut method. And remember, the shortcut method is you take your vertex, which in this case, folks, is 0, 0, because p equals 0 and q equals 0. And then you apply it to the step pattern, which is a times 1, 3, and 5. But a equals 1, so that equals 1, 3, and 5. So I plot my vertex, and then I do the step pattern. So over 1, up 1, over 1, up 3, over 1, up 5. Okay, same on the other side. Over 1, up 1, over 1, up 3, over 1, up 5. Okay. And then give your equation y equals x squared. All right, we're going to be drawing that one several times today, and then we're going to be taking that and shifting it left, right, up, down, and stretching it, etc. Okay, the second method, if you're not sure of how to do that step pattern, is you just realize in your table, hey, I've got these points, negative 3 and 9. So negative 3 and 9, that's this one. Negative 2 and 4, that's this one, okay, etc. And that would still create your parabola. All right, here we go. Using the graphing calculator in the past, in Unit 4, we looked at the effect of A, P, and Q on y equals x squared. Now here's an important summary, guys. I would make sure that you highlight this, study this for your test and for your exam, and I would save it for grade 11 because it's very important. So study for assessments, I'll put on here. When I teach my grade 11s, they like to remember of having this. So it's a good thing to keep. All right, so based on the equation, which is in vertex form, guys, and that's where you can see your transformations, guys, when the equation is in vertex form. You cannot see them when you are in standard or factored form. All right, so we got to take a look at P, and in Unit 4 we discussed P had the shifting left and right, and that is called a horizontal translation. Okay, and just remember that's the one, folks, where you look in this equation and it's the opposite of what's in the bracket because the negative part is part of the formula. Okay, so opposite of what you see is what you're going to say for a p-value, okay? We're going to go over that in a couple examples in a minute or two, okay? Q, ladies and gentlemen, the effect of Q, that does your up and down shift. So that is your vertical shift or vertical translation. Up or down. Okay. And then, ladies and gentlemen, A does a couple things. Okay. So if A is greater than 0, that means it is stretched vertically. Okay, if it is stretched vertically, that means that it gets narrower. Okay, so you might want to write that in. And you're going to ignore the sign for now. We're just going to talk about if the numeric value. Ignore the sign for now. Okay, if A is between 0 and 1, then it is compressed vertically, or you might want to say flattened. A little bit like a pancake. And another term they call is widened for that as well. Okay? All right. And then, ladies and gentlemen, the second aspect of what A does, if A is less than 0 or negative, the graph is reflected. So that means it opens upside down. Okay? So it opens down in that case. Okay? Otherwise, if A is greater than 0, it opens up. All right, a couple things to remember from last day. Vertex is your ordered pair P and Q. The axis of symmetry is based on the first part of the vertex, which is x equals p, and your step pattern is a equals 1, 3, and 5. So what's really neat, folks, here is we're going to do an example, and on the same grid, we're going to show the different transformations, each shift separately. So you're going to need 3 or 4 different colored pencil crayons to do this. Okay, so if you've got some, grab some. Otherwise, pause the video and get some and then come back, okay? All right, hopefully everybody's got their colors with them. Now we're going to take a look at example 2. Use the transformations to sketch the graph of, and notice it's in vertex form, folks. So based on vertex form, A is what value? It's the value out front, so A equals 1. Okay. P, ladies and gentlemen, is what's in the bracket, and it's, remember, the equation is based on x minus p. So how did the negative automatically become a positive? It had to be multiplied by a negative. So p is negative 2. Remember up here, folks, I said it's the opposite of what you see in the bracket, okay, because the negative is part of the formula. Cool. And then, ladies and gentlemen, our Q is what's at the end, and it's negative 4. Those are important pieces of information to help us when we take a look at applying our transformations. All right, so I want you to do some color coding. Get your most basic color, usually your pencil, ladies and gentlemen, to start with your base function. Okay, so it says we're going to, first step to apply the transformations, we've got to graph our parent function. Okay, which is, sorry, our base function. That's another name for base function. You'll learn that in grade 11, folks. Okay, so to graph y equals x squared, we're going to use a shortcut of vertex is 0, 0. Okay, and we know our step pattern is what? 1, 3, and 5. Okay, so let's do that. Over 1, up 1, over 1, up 3, over 1, up 5. Okay, same on the other side. Over 1, up 1, over 1, up 3, and over 1, up 5. Okay? And we're going to label it y equals x squared. Awesome. Okay, now, ladies and gentlemen, we're going to take a different color. So I'm going to start with green, but you choose whatever color you have. And now we're going to take a look at the horizontal shift. Well, what do we know, folks? We know p equals negative 2. So what does that equation look like if we just add that onto our base function? It's going to be y equals x, subtract a negative, which is a positive, and we're going to be squared. Okay. Okay. All right, so what we're going to do, folks, is we're going to graph that. So what does that mean, folks? If P is -2, that means we've got to do a shift in the -2 direction. So -2 means we're going to shift left 2. Okay, so you can do this one of two ways, folks. You can start with your vertex and you can shift it to the left and then apply the same step pattern, or you can take each data point and shift it over 2 points, okay? So I'm going to do the step pattern from the new vertex. So I'm going to go over 1 up 1, over 1 up 3, over 1 up 5, and do that on both sides. Over 1 up 1, over 1 up 3, over 1 up 5. Okay? And that, ladies and gentlemen, is y equals x plus 2 squared. All right. Find a different color, ladies and gentlemen. Actually, not quite yet. I apologize. Take a look at number 3. Are we stretching or compressing? To stretch, ladies and gentlemen, A has to be greater than 1. And to compress, A has to be between 0 and 1. And looking at what we have here, folks, A equals 1. So we're just going to put down NA, or not applicable here, because A equals 1. Okay, so in this case, we don't use that, but we will later on as a step to graph. Next one, it says, take a look at A. We're going to flip it upside down if it is less than 0. A is positive, so that in this case is non-applicable because A is greater than 0. But next time we will. Now, ladies and gentlemen, pick a different color. I apologize about that earlier. Let's take a look at our Q translation. Okay, Q moves it up or down. So if we know Q equals -4, that tells us we're going to go down 4. Okay, so we're going to go down 4. So take from your green vertex, in my case, and you're going to go down 4, 1, 2, 3, 4, and apply the same step pattern. So over 1 up 1, over 1 up 3, over 1 up 5. Okay, same on the other side. Over 1 up 1, over 1 up 3, over 1 up 5. Awesome. And ladies and gentlemen, that is the graph that is for the complete answer. So that is your full equation, which is y equals x plus 2 squared minus 4. So we had to shift it. First of all, we had to shift it to the left 2, the whole parabola, and then we had to shift it down 2. Keep in mind that we could also be doing some stretching and compressing and reflecting, which just wasn't in this first example. I wanted to start off on an easier one. Okay. Let's take a look at another example where it's getting a little harder. We're going to take a look at a little bit more aspects of it in example 3. So in example 3, folks, it says use the transformations to sketch the graph of y equals 2 bracket x minus 4 squared. Okay, so first of all, before we do any graphing, let's take a look at what our A, P, and Q are. Okay, so A is what's out front, so A equals 2. P, ladies and gentlemen, is what's in the brackets, the opposite of what you see, because it's x minus p, remember, in your equation. So P in this case is 4. And Q, ladies and gentlemen, what's the number at the end? Well, hey, it doesn't exist. That means it's got to be 0. All right, so now we're going to do the exact same order, ladies and gentlemen, but let's set up our graph first. In order to do these, you're going to need the same colors that you had in the last example. All right, so step 1 is to draw your y equals x squared graph. We're going to start at the origin, ladies and gentlemen, and do the step pattern. Over 1 up 1, over 1 up 3, over 1 up 5. Okay, same on the other side. Over 1 up 1, over 1 up 3, over 1 up 5. Draw a curve, parabola, and that's y equals x squared. Okay? Change color, ladies and gentlemen. So whatever you use second, I just have to flip back to find out what color I used. I used green next. Okay, so I'm going to grab my green, and we're going to take a look at P. P equals 4, ladies and gentlemen. What does that tell us? It's positive, so it's going to go in the positive integer direction. So that means I'm going to go right 4. So I'm going to take my vertex at 0, 0 and move it to 4 and 0, okay? And then I'm going to apply the same step pattern over 1 up 1, over 1 up 3, over 1 up 5. Do it on the other side. Over 1 up 1, over 1 up 3, over 1 up 5. Okay? Awesome. Now, ladies and gentlemen, we're going to take a look at the third one, that is A. This is the stretch and compress. Last time A was 1, so it didn't do any stretching or compressing. But here we have A equals 2. So therefore, we're going to be stretching because it's greater than 1. Okay? And how do we do the stretching? We take a look at the step pattern. Okay, so for our step pattern, it's A times 1, 3, 5. In this case, A equals 2 times 1, 3, 5. Sorry, I wrote down 6. Let me fix that. Okay, and then we have to figure out our new step pattern because it's changing. So it's going to equal 2, 6, and 10. So from the exact same vertex that we just drew, you can do this new step pattern. So over 1 up 2, over 1 up 6. You won't be able to do the over 1 up 10. Okay, so do it in the other direction. Over 1 up 2, over 1 up 6. 1, 2, 3, 4, 5, 6. And there, ladies and gentlemen, is your new expression. Okay, what would that look like, ladies and gentlemen? That would graph to be y equals 2 bracket x minus 4 squared. And I apologize, we forgot to put our green one on, ladies and gentlemen. So if you can go back and do that, y equals x minus 4 squared. Okay? Awesome. Now taking a look at number 4 and 5. So number 4 is if we have to flip our quadratic. And in this case, A is greater than 0. Therefore, there's no flip because it's positive. Okay. And 5 would be your up-down movement, but Q equals 0. Therefore, there's no up or down movement. Awesome. Now we're going to work backwards, ladies and gentlemen. Now I'm going to give you the graph, and you've got to now create the equation. You can do me a favor, first of all, and put arrows on your quadratic. That would be awesome. So in order to write my equation, eventually it's got to be in vertex form, which is A bracket x minus p squared plus q. So what 3 letters do we need to find out? We need to find out what A equals, and we need to find out what P equals, and we need to find out what Q equals. Then we can sub them into the equation. Okay? Taking a look, folks. Sorry for the announcement. Sorry, guys. Okay, so vertex, ladies and gentlemen, is -2 and 3. But remember, folks, the vertex is your P and your Q. So that gives us 2 pieces of the information. So I apologize. It's -2 and 4, guys. Okay, so that's going to give us our P equaling -2 and our Q equaling 4. And the last thing we need to figure out is A. Okay, first of all, what do we know about our direction of opening? Our direction of opening is down, so we know automatically that A has to be negative, right? Okay, because it opens down. And then we're going to use the step pattern, folks, from our graph. So as I start at my vertex, I go over 1, I go down 1/2, so that's -0.5. Okay? As I go over 1, I go down 1.5. Okay? As I go over 1, I go down 2.5. And so that's our step pattern. So based on our step pattern of -0.5 and -1.5 and -2.5, how does that relate to our step pattern of A times 1, 3, and 5? Well, hopefully you realize that A has to be -0.5 or A has to equal -1/2. I prefer the fraction, ladies and gentlemen. Okay? So now that we've got A, P, and Q, we just have to sub them in and we are done. So y equals -1/2, that's your A, bracket, x plus 2, because you subtract a negative, it becomes positive, and plus 4. So there is your equation, ladies and gentlemen. Okay, so you got to use the tools that you're given. Use that summary chart to help you do your homework, which is page 306, numbers 1 to 8 and 10. Thanks and have a great day.